Hello, my name is Piers Messum. This is the presentation I gave in June 2016 at the New Sounds Conference held at Aarhus University in Denmark. As the title suggests, it's in two parts. In this part, I'll discuss how children learn to pronounce the speech sounds of their mother tongue and question the long-standing assumption that they do this by imitation. In the next part, I'll look at the implications for older learners of second languages. What can we learn from carefully analysing their situation in the light of how children might learn to pronounce? What I'm about to present is also available on paper. Last year, Ian Howard and I published a careful analysis of two theories of how children learn to pronounce L1 speech sounds in the Journal of Phonetics. It's an open access paper that's free to download from the link in the information panel below. To discuss this topic, we need to be clear about the relationship between two distinct processes. One is learning the pronunciation of a new word. Let's do this through an example. I'll say an English word that may be new to you, and then I'll pause. Please say the word out loud, and notice that you'll probably pronounce it either perfectly or very well. What do you do to immediately learn the pronunciation of this word and then perform it? You may want to pause the video after I say the word to consider this question. The word is horripilation. Did you copy an acoustic image, a whole word shape, as depicted in the top of this slide? I suspect not. If you had, you would have sounded like me, with any idiosyncrasies of my pronunciation copied into your production of the word. Instead, I'm sure you broke it down, parsed it into segments. 3, 4, or 5 speech sounds that you know how to reproduce. Perhaps 4, horripilation. Then, you produced a string of sounds in your own voice using 4 motor patterns that you know will produce something equivalent to the speech sounds that I said. Celia Hayes, who works on imitation in humans and animals, has developed this style of diagram to show what's going on. The speech sounds you heard in horripilation are the 4 sensory experiences running across the top. Having recognized these, you could produce your equivalents to them using the 4 motor patterns across the bottom. However, this relies upon some prior learning. Sometime in the past, you learned to connect speech sounds you hear to motor patterns you produce, the vertical red lines in the diagram. For example, you learned that the experience of hearing other people say ho can be linked to actions which produce a short back vowel with slightly rounded lips and a breathy onset. The noise this produces will be taken to be equivalent to ho by your listeners. The so-called correspondence problem for speech sounds is the question of how someone creates those links. That's the problem we call learning to pronounce rather than learning to pronounce words. And the question about to be addressed is this: when and how does that prior learning occur in children? Broadly speaking, there seem to be 2 possibilities. The first possibility is that a young child imitates what he hears the people around him doing in an auditory matching to target process. This is the long-standing, widely held, conventional assumption about the process, but one which has no experimental and no observational evidence for it. It is just an assumption, probably made because most people haven't realized that there is any alternative to it. It could work something like this. The child's caregiver produces a speech sound embedded in a word or phrase, number 1 in the diagram. The child hears and attends to this, number 2. He tries to produce something to match it, number 3, then compares, number 5, what he hears of himself, number 4, to what he has heard, number 1 again, and tries to improve what he does to make it more similar in the future, number 6. Alternatively, perhaps he's heard his mother say this and other speech sounds on repeated occasions in the past, and he has created an internal representation of the sound from these events. When he now attempts to produce the sound himself, he uses this internal representation as his guide, evaluating his effort against it and improving his subsequent attempts this way. Now, whether this model is something he's just heard or something he evokes from memory, he's using an auditory image to develop his production, and solving the correspondence problem by matching this target ever more closely. It is his judgment of similarity or otherwise between the tokens that drives the process. But there are various potential problems with this account. One is the normalization problem, arising from the different sizes of the child and adult vocal tracts. The fact is that a child cannot objectively match what his mother produces, and how an immature and inexperienced speaker would make a judgment of similarity in these circumstances is not clear. There are other potential problems, and these are described in the Journal of Phonetics article. The first person who offered an alternative vision of the infant learner of speech that we're aware of was the educationalist Caleb Gattegno. Gattegno is best known in the English-speaking world for his work as a maths educator, but he also worked on literacy, and he was the inventor of the silent way of language teaching, which he developed from the 1950s until his death in the 1980s. He also studied learning across the human lifespan and wrote about the scientist in the crib many years before this idea entered the mainstream. The learning paradigm we need to consider is mirroring. This is a common mechanism we use for finding out about ourselves. When we are unable to see ourselves as others do, we can use an actual or a metaphorical mirror to fill the information gap. Ballet dancers look at themselves in mirrors, because otherwise they can't see themselves as the audience will. But we also use other people as mirrors. We ask, how do I look? For a similar reason. And we find out more subtle aspects of ourselves from the reactions we see in others that they make to our words and behaviours. For example, human babies are believed to learn about their affective states from observing their caregivers' responses, at a much earlier age than the onset of speech. So this mirroring mechanism of discovery about themselves is potentially available to young talkers. How is mirroring relevant to learning speech sound correspondences? We propose that it operates during the imitative games that caregivers play with their children. This is one of the most striking aspects of caregiver-infant interaction. These games involve all forms of action, but are very often concerned with sound making. On the slide, there's some data from an early video study done by Susan Paulby with 8 mother-infant pairs collected in 191 10-minute sessions of play at different infant ages. This is just the data for speech-like sounds, coded on the basis of who started the interaction and who followed. So in the first line, the infant made a noise and the mother imitated it. Notice who does the imitation. Mothers imitate their children around 10 times as often as infants imitate their mothers. This has been confirmed by many other studies. What is also found, and was confirmed in the experiments that Ian Howard and I did, is that caregivers don't mimic what their infants say. The caregiver's utterances are usually well-formed tokens of L1, produced as if their infants had said something in L1 to them and they were responding appropriately. This offers a potential solution to the correspondence problem for speech sounds, which has been investigated by the Asada group in Japan as well as by Ian and me. We call it a mirrored equivalence paradigm. The process starts with the child making a speech-like noise, using a vocal motor scheme that he has developed during the babbling phase, for example. His mother hears this and interprets it as being similar to some L1 speech sound. She reformulates his noise into a well-formed token of L1 and reflects this back to him. He hears this and understands the context, that this is an imitative interaction between them. So he knows that she must regard what he did and what she produced as being equivalent. By accepting her judgment in this, he has a solution to the correspondence problem for a speech sound. We don't have to credit the infant with these deductive powers. We can see it another way if we note that the mother's response is contiguous, it happens straight after his, and highly contingent upon his action. So simple associative learning, as would be expected in these circumstances, is another way of understanding the process. This mechanism relies on his mother imitating the infant, but not on imitation on his part. It's described more carefully in the Journal of Phonetics article, and its implications for other aspects of speech development are analysed there. In the second part of this presentation, I'll look at the implications of this for how we teach speech sounds to older learners who are students of a second language.